Hi students, today let us see what is Gauss's theorem or Gauss's law in chapter 1 electrostatics of your class 12. Okay, in today's class I'll only be telling you the definition. Applications I'll put a separate video. Okay, so Gauss's theorem or Gauss's law in electrostatics, and I will also tell its significance. Gauss's law, first let us write the statement. Okay, Gauss's law states that the total normal electric flux passing through any closed surface is 1 by epsilon naught times the net charge enclosed by the surface. So, what is Gauss's law? Gauss's law states that the total normal electric flux passing through any closed surface is 1 by epsilon naught times the net charge enclosed by the surface. And this is also represented using the in the same way we represented flux we represented using phi. Here also we are using phi. Phi is equal to E into ds, which is equal to Q by epsilon naught. Okay, this epsilon naught you write as C and put a line, epsilon naught. So, phi is equal to E into ds, which is Q by epsilon naught. This is all about Gauss's law. Okay, Gauss's law states that the total normal electric flux passing through any closed surface is 1 by epsilon naught times the net charge enclosed by the surface. And here a necessary condition is in order to apply the Gauss's theorem to any object or any surface, it should be closed. We need a closed surface here. This is compulsory. Okay, closed surface should be given to us. Only then we can apply Gauss's law or Gauss's theorem. So, Gauss's law states that the total normal electric flux passing through any closed surface is 1 by epsilon naught times the net charge on it. Now, okay, now let us see what is the significance. Okay, significance of this. Significance is that isolated charges can exist. The significance of Gauss's theorem or Gauss's law in electrostatic is that isolated charges can exist. Isolated charges can exist. Okay. So, once again Gauss's theorem states that the total normal electric flux passing through any closed surface is 1 by epsilon naught times the net charge enclosed by the surface, and it is we are representing it using phi, which is Q by epsilon naught. And in the last class we represented phi using E into ds, right? So here, in order to use this equation, area should be given, electric field should be given, all those should be given in order to find the flux, right? So we can also find flux using this equation, Q by epsilon naught, which we got from Gauss's theorem. Phi equals Q by epsilon naught, we got it from Gauss's theorem. This equation can also be used to find flux. So Gauss's law states that, you know the statement, right? It is very, very important. The significance is that isolated charges can exist. And in the other video which I took on electric flux, please note down this point too. Electric flux is dependent on the charge enclosed by the surface. It also depends on the magnitude and direction of the electric field. Electric field is dependent on the charge enclosed by the surface, and it also depends on the magnitude and direction of the electric field. This is a point which I should have said, I should have told you in the flux when I took flux, but then I just missed it out. So please note this down too. Electric flux is dependent on the charge enclosed by the surface. It also depends on the magnitude and direction of the electric field. Then, so this is about about Gauss's theorem. That's all which I had to say. The definition, that means the statement, the equation, then the significance, then there are applications of Gauss's theorem. And the applications, there are 3 applications, and for each of the application I'll put a video, so do check it out. Okay, so that's it with today, Gauss's theorem and its significance. So see you in the next class with the applications, the first application of Gauss's theorem. Till then, stay tuned. Bye bye.